Deep Space Energy, a Latvian space startup founded in 2022, is developing heat and power systems based on radioisotope materials. Radioisotope materials are specific versions or isotopes of chemical elements that are unstable. They spontaneously break apart, emitting electrons or sometimes particles at very high speed. These particles strike the surrounding material, releasing heat. Using a simple device called a thermocouple, which has no moving parts, a small amount of the thermal energy can be converted into electrical energy. These systems work for decades, producing reliable energy 24/7 with no moving parts. They're perfect for places where solar panels wouldn't work. You can see why space agencies and startups are keen on using these systems in orbit, on the Moon and Mars. The company is a spin-off from the Institute of Physics at the University of Latvia. Their goal is to become a commercial supplier of radioisotope electricity, commonly referred to as radioisotope thermoelectric generators or RTGs. They're focusing on missions to the Moon and Mars. RTGs would be especially helpful for heating rovers, landers and scientific equipment on the Moon during the lunar night, where temperatures plunged to as low as -173 degrees Celsius for 2 weeks. For Mars, due to dust storms, solar energy may not be available, so alternative or backup power systems are needed. Vision. On their website, Deep Space Energy defined their mission as providing clean, uninterrupted power to places the sun can't reach by turning the constant heat provided by unstable elements into reliable watts for spacecraft, lunar factories, and critical assets on and above the Earth. The startup says that a thriving off-world economy needs utilities, not batteries. By 2040, they aim to supply gigawatt hours of nuclear electricity to missions from low Earth orbit all the way out to the Kuiper Belt. The Kuiper Belt, by the way, is 30 times further from the Sun than Earth. Pluto orbits the middle of the Kuiper Belt and is one of the largest objects in the belt, as well as being the 9th planet. These RTG systems are hot rocks in a box, as Xenopower's CEO colourfully called these types of systems, enable permanent science outposts, resource extraction, and reliable communications networks. Leadership. The company was founded by Dr. Mihalis Szczepanskis, a scientist and entrepreneur. He is the CEO of Deep Space Energy, and his leadership team includes world-leading experts in electromagnetic systems, including a professor at Coventry University in the UK, who is the chief scientist of the startup. 2 hubs, 1 team. The company has 2 offices, the first in Riga, Latvia, and the second in Coventry, United Kingdom. With the company's Baltic talent blended with the UK's research depth, the company is able to tap into the European supply chain for fuel, machining, and test facilities. Europe, especially France and the United Kingdom, operate large-scale commercial reprocessing facilities, such as Le Hague in France and Sellafield in the UK. A common byproduct from reprocessing spent nuclear fuel is strontium-90, a strong emitter, which is available in quite high amounts, at least compared with other radioisotope elements. For instance, Xenopower, a competitor, is using strontium-90 in their nuclear batteries. The US dominates the market for plutonium-238, a possible alternative radioisotope element for nuclear power systems, while strontium-90 can be sourced entirely from Europe and eliminates the US dependency. Plutonium-238 is costly and hard to work with because of the risks of nuclear proliferation. With the need for radioisotope materials soaring, alternative radioisotope materials are needed. Even NASA is looking at alternatives such as americium-241. Radioisotope Thermo-Acoustic Linear Induction Generator, or RTALIG. Deep Space Energy has developed their proprietary power system called RTALIG, which delivers 25% efficiency, putting it in the same range as NASA's cancelled Advanced Stirling Generator design. For comparison, typical RTGs convert between 5 to 7% of the energy into electricity. The company has fuel flexibility as their power systems run on americium-241, plutonium-238 or strontium-90. With a 25% conversion efficiency, their power system requires 5 times less fuel than a standard RTG. Or alternatively, For the same amount of fuel, their system provides 5 times the power. Reliable by design. All mechanical systems break down eventually due to wear and tear. With only one piston, there's less to move and less to break. Their system is rated for 17 years of continuous operation. Each module from Deep Space Energy provides 50 watts of electrical power. A stack of 10 units can provide 500 watts or half a kilowatt of power. Each 50 watt module weighs 22 kilos, that's about 50 pounds. This efficiency is essential because the cost of a single kilogram of plutonium-238 or americium-241 is millions of dollars and is quota limited. Deep Space Energy's power system can turn 2 kilos of americium-241 into 50 watts of electrical power. That saves mass, money, and export-controlled material. For instance, the US makes it much easier to fly small amounts of radioactive materials into space, so a highly efficient power system from Deep Space Energy would not face burdensome licensing and regulations that larger, less efficient power systems would. Funding from the NATO Defence Innovation Accelerator. A grant of €100,000 was provided to a number of companies, with Deep Space Energy being one of those companies. This support could eventually increase to €300,000 with continued success in the accelerator. Power as a service, Deep Space Energy's business model. The company doesn't sell hardware. Instead, they deliver watt-hours on orbit or on surface under a service contract. The reason, or one of the reasons, is that as a European space startup, the company needs to comply with a lot of regulation, more than their US counterparts. One such piece of regulation are the licensing requirements that deal with nuclear materials. Strontium-90 is classified as a controlled fission product, which complicates selling power systems to clients. Deep Space Energy gets around this issue by selling power as a service. Throughout the system's life cycle, the startup retains legal ownership and therefore cuts out licensing issues with the transfer of ownership of radioisotope materials. Just handling radioactive materials entails stringent national and EU-level regulations, Euratom Treaty provisions, and IAEA-aligned safety standards. Transferring ownership would, in addition to the previous issues, add import-export controls, additional licensing, security obligations, and liability burdens for the customer, which may lack the specialized nuclear expertise or authorizations. To avoid adding these burdens to customers, Deep Space Energy owns and operates the power systems and sells the power to the customer instead. Deep Space Energy says on their website, "Pay for what you consume. No capital expenditure is needed by the customer. Once the mission ends, they redeploy the generator to the next customer, maximizing isotope use." The ecosystem, competitors, funding, and supply chain. There are not many space startups working with radioisotope power systems. One reason is licensing and regulation is a problem when dealing with nuclear materials. However, nuclear batteries are extremely useful in many applications due to their simplicity and ease of use. As mentioned before, they can be considered hot rocks in a box, in their simplest application as heating units. For lunar night survival, radioisotope heating units are enough to allow valuable lunar assets to survive until the sun rises again 2 weeks later. Xenopower recently signed a deal with iSpace to supply nuclear batteries to help their future lunar rovers survive the lunar night. Another possible use is for stealth satellites. At the moment, large solar panels are needed to produce significant amounts of power. These solar panels light up a satellite, making it a sitting duck for anti-satellite systems. A nuclear battery-powered satellite would be almost invisible to detect, visually at least, against the blackness of space. For Mars, nuclear power systems are essential due to the unpredictability and longevity of dust storms, which would quickly cover solar panels. From the graphic, we can see that only Xenopower is close to having commercial systems on the market, either in 2026 or perhaps 2027. Strontium-90 appears to be the favorite radioisotope element, perhaps because it's relatively cheap and available in large quantities, meaning power systems can be produced at scale.
The downside to strontium-90 is its half-life of only 29 years. That means every 29 years, half of the radioisotope is lost due to radioactive decay, resulting in declining power levels, which limits the lifetime of the power system. Upcoming events. In 2027, Deep Space plans a functional validation demo of their RTALIG system. The next year, they will demo a prototype for Lunar and Mars rovers. In 2029, they plan an in-orbit demo mission with commercial sale of systems starting in 2030. What do you think of using radioisotope power systems for heating and electrical power in space on the Moon and Mars? Leave your thoughts and opinions in the comments section below. Thanks for watching. If you enjoyed this space video, consider buying me a coffee to help fund more episodes like this. The link is in the description. Space News Live is on Saturday evening or Sunday morning, depending where you watch from. The live stream is a great way for you to share your thoughts and opinions on the videos I posted this week, or on any space topic in general. I highlight the most thought-provoking comments on videos I've received, along with previews of upcoming content. If you got the time, please tune in and say hi. Be sure to like and subscribe so you'll see our upcoming videos. We make videos every week covering the space industry with an emphasis on the smaller space startups that aren't covered so well on other channels. See you soon.